Welcome to Deltaplex Live, the real-time enterprise show. I'm Alex.
And I'm Maya. This is our very first episode, and we're starting with a topic that sits right at the center of where enterprise technology is going: AI agents, real-time data, and the operational systems that make business actually run.
Today's episode is called AI Agents Are Only as Good as Their Data. And that might sound simple, but it's becoming a very serious question for enterprises. Because right now, a lot of companies are experimenting with AI agents. They're building internal assistants, customer service agents, fraud review agents, workflow automation agents, all kinds of exciting things. But once those agents move from demo to production, one question becomes critical. What does the agent actually know about the business at the moment it makes a decision?
Exactly. And that's where real-time operational data becomes so important. In a demo, an AI agent can look impressive using sample data, static documents, or a carefully prepared workflow. But in the real world, business changes constantly. An order gets canceled, a payment goes through, inventory drops, a shipment is delayed, a customer updates their account, a risk signal changes. And if the agent doesn't see those changes in time, it may still give you an answer, but that answer may be based on the wrong version of reality.
Right. So today, we're not just talking about AI models. We're talking about the data foundation behind AI agents, the operational context that comes from databases, applications, event streams, workflows, and legacy systems. Because if enterprises want AI agents to work safely in production, the agents need more than intelligence. They need fresh, trusted, governed context.
That's exactly the point. AI agents are moving from passive assistants to systems that can observe, reason, recommend, and in some cases, take action. So the data layer has to change as well. Yesterday's reporting snapshot is not enough. Fragmented system integrations are not enough. Directly querying production systems is risky, and governance cannot be something you add later.
So in this first episode of Deltaplex Live, we'll break down why AI agents raise the bar for enterprise data infrastructure, why batch pipelines and siloed systems create problems, and how companies can start building a real-time operational context layer. We'll also talk about what this means for use cases like fraud review, customer service, inventory operations, and compliance.
And we'll keep it practical. The question is not simply, can we build an AI agent? The better question is, can we give that agent the right data at the right time with the right governance, without putting core systems at risk?
Exactly. So let's get into it.
Maya, let's start from the beginning. For years, enterprises have been building data warehouses, BI dashboards, reporting systems, and analytics platforms. So what changes when AI agents enter the picture?
The biggest change is that traditional analytics is usually passive. A dashboard helps people understand what happened yesterday, last week, or last month. If a report is delayed by a few hours, that's not ideal, but in many cases, the business can still use it. AI agents are different. They're designed to work inside live business processes. They observe what's happening, reason about it, recommend next steps, and sometimes even take action. So the data they use has to be much closer to the current state of the business.
So it's not just about having data. It's about having data that reflects what's happening right now.
Exactly. Let's take customer service as an example. A customer asks, "Where is my order?" A human support agent or an AI service agent needs to know the latest order status, payment status, delivery status, refund history, and maybe previous support tickets. If the AI agent is using data from yesterday or even from 2 hours ago, it might say, "Your order is on the way," when actually the order was canceled 10 minutes ago.
That's a bad customer experience.
It is, and in some use cases, the impact is even more serious. Think about fraud review. If an agent is helping detect suspicious transactions, it needs very fresh signals: recent transactions, account history, device behavior, customer activity, location changes, and risk scores. If those signals arrive too late, the agent is not really reviewing the current risk. It's reviewing an old snapshot.
So the agent may sound confident, but it could be confidently wrong.
Exactly, and that's the danger. A better AI model does not automatically solve bad context. If the data is stale, incomplete, or ungoverned, even a very advanced AI agent can make poor decisions.
That's a good way to frame the whole episode. AI agents are only as good as the context they're working with. Let's talk about batch data. A lot of enterprise data pipelines still run hourly, daily, or overnight. That has worked for many reporting use cases. Why does that become a problem for AI agents?
Batch pipelines were built for a different type of decision making. They're useful for reporting, financial reconciliation, management dashboards, and historical analysis. But many AI agent workflows operate inside short decision windows. If the agent needs to make or recommend a decision in minutes, then a data pipeline that updates every 6 hours is too slow.
Can you give an example?
Sure. Imagine an inventory operations agent. It monitors product demand, stock levels, supplier updates, and warehouse activity. If sales suddenly spike, the agent may need to recommend replenishment or flag a stockout risk quickly. But if inventory and sales data are only updated overnight, the agent may not see the problem until the opportunity has already passed.
So by the time the data arrives, the business moment is gone.
Exactly. Another example is risk monitoring. If a bank or financial institution is reviewing transactions, account behavior, or suspicious activity, a delay of several hours can create real blind spots. The issue is not that batch data is useless, it's still valuable for many things. The issue is that AI agents need data freshness that matches the workflow.
So, not every workflow needs millisecond latency.
Right, that's important. The goal is not always instant data for everything. The real question is, how fresh does the data need to be when the agent makes a decision? For some workflows, minutes may be fine. For others, seconds matter. But yesterday's reporting snapshot is usually not enough for production agentic workflows.
Another big issue is that enterprise data is often spread across many different systems. Why is that such a challenge for AI agents?
Because AI agents rarely need data from just one system, let's go back to the customer service example. To answer one customer question properly, the agent may need CRM records, recent orders, payment status, shipment updates, product inventory, support history, and SLA commitments. Those data points often live in different systems, owned by different teams with different schemas and different update frequencies.
So the agent needs a complete business picture, but the data is fragmented.
Exactly. And when companies don't have a shared data foundation, every new AI workflow becomes a custom integration project. One team connects the agent to the CRM, another team connects it to the order database, someone else builds a custom API for payment status. Then another agent needs similar data but not exactly the same data, so the team starts building again. That approach may work for one or two pilots, but it becomes hard to scale and hard to govern.
It sounds like old point-to-point integration problems, but now AI agents make the problem more urgent.
That's exactly it. AI does not remove the integration challenge. In many cases, it exposes it. If the enterprise has fragmented systems, inconsistent data movement, unclear ownership, and weak governance, AI agents will run into those problems very quickly.
So what's the better approach?
The better approach is to build a governed operational context layer. Instead of connecting every agent directly to every source system, the enterprise creates a shared layer where relevant operational data is continuously captured, delivered, monitored, and governed. Agents can then consume trusted context from that layer.
So the agent doesn't have to understand every backend system directly.
Exactly. The agent gets the context it needs, while the enterprise keeps control over data movement, access, freshness, and governance.
Let's talk about direct queries. In a demo, it can feel very natural to let an AI agent query a production database or API directly. Why is that dangerous in production?
In a demo, direct querying often looks fine. You have one agent, a limited number of test users, and a controlled environment. But in production, the scale is very different. You may have hundreds or thousands of agent actions happening at the same time. Each action may trigger queries against operational databases or business APIs. That creates unpredictable load on source systems.
And those systems are already supporting the real business.
Exactly. Your production database may be handling orders, payments, customer records, inventory updates, or account changes. You don't want AI agents adding uncontrolled query pressure to those systems. If agent usage spikes or if a workflow behaves unexpectedly, it could slow down critical applications.
So this is not only a data architecture problem, it's also an operational reliability problem.
Yes, for enterprise AI agents, source system protection matters. The data layers should provide fresh data without repeatedly hitting critical production systems. That's where non-intrusive capture becomes important.
Can you explain that in simple terms?
Sure. One common method is change data capture, or CDC. Instead of repeatedly asking a database, what changed, what changed, what changed, CDC reads committed changes from database logs. So when a record is inserted, updated, or deleted, the change can be captured and delivered downstream.
So it's more like listening for changes instead of constantly knocking on the database door.
Exactly. That's a simple way to think about it. CDC helps enterprises move operational data in near real time while reducing the impact on production systems. For AI agents, that means fresher context with lower operational risk.
Now, let's talk about governance. A lot of companies think governance is something they can add after the pilot works. Why is that risky for AI agents?
Because AI agents can influence decisions and workflows, when an agent recommends something, routes a case, flags a transaction, or triggers an action, the enterprise needs to understand the basis for that action. What data did the agent use? Where did that data come from? Was it current? Was sensitive information protected? Who had access to it? Can we reconstruct the decision context later? Those questions are not optional in production.
Especially in industries like banking, insurance, healthcare, logistics, or any regulated environment.
Absolutely. If an AI-enabled workflow affects customers, risk decisions, compliance processes, or business operations, companies need auditability. Without governance, the enterprise may not be able to explain what happened. And if you cannot explain what happened, it becomes very difficult to trust or scale the system.
So, governance is not just about compliance, it's also about trust.
Exactly. Governance is what allows people to trust that the agent is using the right data, under the right controls, with the right level of visibility. That includes lineage, metadata, access controls, masking rules, audit logs, and monitoring.
You also mentioned schema changes earlier. Why do they matter for AI agents?
Because source systems change all the time, a team may add a new column, rename a field, change a data type, or modify a table structure. For a dashboard, a broken field is annoying. For an AI agent, a silent schema change can be dangerous. The agent may continue working, but with incomplete or incorrect context.
So, it might not fail loudly, it might fail quietly.
Exactly. And quiet failure is risky. Production data pipelines need schema resilience. They should detect source changes, manage them, and communicate them to downstream consumers before agent behavior is affected.
Let's summarize this. If an enterprise wants to move AI agents into production, what does the data layer need to provide?
I'd break it down into 6 requirements. First, low latency data movement. The data layer must support timely delivery when the decision window is short. Second, unified context. Operational data from different systems should be delivered into a consistent layer that agents can reason over. Third, non-intrusive capture. Real-time movement should not depend on repeated queries against critical source systems. Fourth, schema resilience. The system should detect and manage source changes, so downstream workflows don't silently break. Fifth, governance by design. Lineage, audit logs, access controls, and masking rules should be part of the architecture before launch. And sixth, operational observability. Teams need to monitor latency, freshness, errors, throughput, and downstream delivery.
That's a very practical checklist, and it changes the conversation. Instead of asking, can we build an AI agent? Leaders should ask, can we safely give this agent the operational context it needs?
Exactly. The agent is only one part of the system. The data foundation around the agent is what makes it production ready.
Let's describe what a production-ready architecture might look like. Not too technical, but enough for leaders to understand the shape of it.
A practical architecture usually has 5 layers. The first layer is operational systems. These are the systems where business actually happens: databases, SaaS applications, event streams, and legacy platforms. The second layer is the capture layer. This is where the enterprise captures changes from those systems using CDC, event capture, or controlled replication. The third layer is the governed delivery layer. This is where schema handling, lineage, access control, monitoring, and delivery rules come in. The fourth layer is the AI context layer. Depending on the use case, this could be a feature store, vector database, lakehouse, real-time store, or another environment where agents can access trusted context. And the fifth layer is the agentic workflow itself. That could be fraud review, customer service, inventory optimization, risk monitoring, compliance, or operations automation.
I like this structure because it separates the agent from the complexity of all the back-end systems.
Yes, and that separation is important. The goal is not simply to move data faster. The goal is to make operational context reliable enough for autonomous or semi-autonomous systems to use safely.
That's a strong point. Speed alone is not enough. The context has to be trusted.
Exactly. Fast but unreliable data can still create bad decisions. Production AI needs freshness, completeness, governance, and reliability together.
Let's go through some practical use cases. Where does this kind of real-time operational context matter most?
One strong use case is fraud and risk review. A fraud agent may need transaction data, account history, customer behavior, device signals, and risk scores. If that context is fresh and traceable, the agent can help reduce blind spots and improve decision quality.
And if the data is stale?
Then the agent may miss important signals. It may review a transaction without seeing a recent account change, a suspicious login, or a new risk event. That can lead to poor decisions. Another use case is customer service routing. A service agent needs order status, account state, payment records, SLA commitments, and support history. With fresh operational context, the agent can route cases more accurately, answer questions faster, and reduce manual investigation.
That seems very relevant for large enterprises with high support volume.
Definitely. Then there is inventory and operations optimization. An agent may monitor sales, inventory, supplier updates, shipment events, and warehouse activity. If something changes quickly, the agent can flag exceptions, recommend replenishment, or help operations teams respond faster.
And compliance?
Compliance and audit workflows are also important. AI-enabled workflows need transparency. Teams need lineage, policy checks, movement logs, exception records, and audit visibility. The question is not only, did the agent take the right action? It is also, can we explain what data the agent used and why the action happened?
Let's bring Deltaplex into the conversation. How does Deltaplex support this kind of AI-ready operational data foundation?
Deltaplex helps enterprises turn operational data into a governed, real-time context layer. One key capability is real-time CDC with low source impact. Deltaplex uses log-based change data capture to read committed changes from source systems instead of repeatedly querying production tables. That helps teams deliver fresh operational data while reducing pressure on mission-critical systems.
So it helps with both data freshness and source system protection.
Exactly. Deltaplex also connects across different operational environments, databases, applications, event streams, and legacy systems. And it can deliver data into downstream environments such as data warehouses, lakehouses, real-time stores, vector databases, and AI platforms.
That matters because different AI workflows need different kinds of context.
Right. Some agents need structured, real-time operational data. Some need historical context in a lakehouse. Some may need embeddings in a vector database. Some use cases need all of the above. Deltaplex also helps with schema change detection and handling. When source systems evolve, downstream consumers can adapt with fewer failures and less manual intervention.
And on the governance side?
Deltaplex supports lineage, metadata capture, audit visibility, and access controls across data flows that helps teams understand where data came from, how it moved, and where it was consumed. And deployment control is another important point. Deltaplex can be deployed on-premises, in a VPC, or in hybrid environments. That gives enterprises more control over sensitive operational data, data residency, and infrastructure governance.
So for enterprises that cannot simply send everything to a public cloud, that flexibility matters.
Very much, especially for regulated industries or organizations with strict internal data policies.
This can sound like a big architecture project. Do companies need to rebuild everything before they can use AI agents?
No, and honestly, they should not try to do everything at once. The practical approach is to start with one narrow, high-value workflow.
What makes a good first workflow?
A good first workflow is one where fresh operational context clearly affects business value. For example, fraud review, customer service routing, inventory exceptions, operational risk monitoring, compliance review. The company should be able to say, if the agent has fresher and more complete context, we can reduce manual work, improve response time, lower risk, or improve customer experience.
So don't start with a vague AI project. Start with a specific business problem.
Exactly. Then map the required context. Usually that means identifying the 3 to 5 systems the agent must understand to make a reliable decision. After that, build the context layer. Move operational changes into the selected environment. Validate latency, completeness, schema handling, and source system impact. Then govern before scaling. Set up access controls, masking rules, lineage capture, and audit logging before the workflow becomes production critical.
And only after that, expand to more systems and more agents.
Right. Start small, prove value, then scale the architecture. That is much safer than trying to connect every agent to every system from day one.
Let's make this even more concrete. What could a 90-day action plan look like?
In the first 30 days, the focus should be agent data readiness. Pick the priority use case, map the source systems, measure the current data freshness, identify governance requirements, define success metrics. The goal is clarity.
So the first month is not about building everything. It's about understanding what the agent actually needs.
Exactly. Days 31 to 60 are about building the pilot context layer, set up CDC pipelines, deliver the initial operational data, add monitoring, configure access controls, validate latency, completeness, error rates, and downstream delivery.
And days 61 to 90?
That's about preparing for production rollout. Create a run book, define ownership, confirm success metrics, review risks, prepare the expansion roadmap, and bring leadership into the review.
That feels practical. It avoids the trap of building a huge platform before proving business value.
Exactly. The first goal is not to solve every data problem in the enterprise. The first goal is to prove that a governed real-time context layer can make one high-value AI workflow safer and more effective.
Before we wrap up, let's give leaders a simple checklist. If a company is planning to move AI agents into production, what should they ask?
Here are the questions I would start with. Does the agent have access to current data from all required systems? Are source systems protected from unpredictable query load? Can we reconstruct what data the agent used? Are lineage and access controls built into the workflow? Is sensitive data handled according to internal policy and regional requirements? Can teams monitor pipeline freshness, errors, and delivery status? Can teams pause, replay, recover, and audit data flows when needed? And does the first use case have clear business metrics before broader expansion?
That last one is important because otherwise AI agents become a technology experiment instead of a business capability.
Exactly. The goal is not to say, we have an AI agent. The goal is to make business operations faster, safer, and more intelligent.
So the big takeaway from today's episode is this. AI agents are not just about models, they're about context. If agents are going to work inside real business workflows, they need fresh, unified, governed, and reliable operational data.
And enterprises should avoid connecting every agent directly to every system. That may work in a demo, but it creates risk in production. The better path is to build a governed operational context layer, one that captures real-time changes, protects source systems, supports governance, and gives agents trusted context to work with.
And companies don't need to boil the ocean. Start with one high-value workflow. Prove the business value, then expand step by step.
Exactly, because at the end of the day, AI agents are only as good as the context they're working with.
That's a great place to end. Thanks for joining us for the first episode of Deltaplex Live, the real-time enterprise show. I'm Alex.
And I'm Maya. In the next episode, we'll continue exploring how enterprises can prepare their data infrastructure for real-time AI, automation, and decision intelligence.
Thanks for listening, and we'll see you next time.